Hello and welcome to Module 3 of Geography. In this module, we shall be discussing landform and physical features of the Earth. That is the exploration of Earth's dynamic sculpture. The module content here include mountain, that is formation and types, hills and hill range, plateaus, characteristics and example, plain, formation and importance, and landform processes, that is erosion, weathering, and disposition. And we will now draw our conclusion. Let us begin with the introduction. That is the introduction to the Earth's dynamic stage. The key concept: Earth's surface is dynamic, ever-changing mosaic. The two great sculptors that influence mountain are two major forces, which is number one, endogenic forces, which is internal forces, which is always constructive forces. Example, plate tectonics and volcanisms. And the exogenic forces, which is external, usually destructive and reshaping forces. Example, weather and erosion. So these are two major forces that shape the Earth's surface. The significance is this: landforms are not just sceneries. They dictate the climate, influence ecosystem, control resources distribution, and determine pattern of human settlement and civilization. Now, let us look at mountain. That is the Earth's majestic peak. Definition: mountain may be defined as the natural elevation of the Earth. It is massive landform rising prominently above 600 meters with steep slopes. So mountains are just natural elevation of the Earth, usually above higher ground. So they are usually above 600 meters within their surroundings. The primary force is just like we said, the process of formation of mountain is known as orogeny, which is mountain building, which is driven by plate tectonics. The formation. The formation results from immense pressure at plate boundaries, which is usually in form of collision, subduction, or divergence. Now let us look at types of mountain. One, we have fold mountain. How does it form? It is formed by compression of multiple rock layers like rock. The feature is that fold mountains are usually longer linear range, parallel ridges and valley. Example is Himalayas, that's Indian Eurasia Coalition. So it is formed by Indian Eurasia Coalition. So a very good example of fold mark is Himalayas. Number two types of mountain is block mountain, otherwise known as fault mountain. It is formed by cross stretch, fractures and blocks are uplifted and dropped. The feature include it is usually steep escarpment, flat top or tilted blocks. Example is Sierra Nevada in US. So it is example of a block mountain. Still on types of mountain, we have volcanic mountain, which is formed by the accumulation of lava, ashes, and pyroclastic materials. There are of two types, that is stratovolcanoes, which is cone shape, and shaped volcanoes, which is broad shape. Example is Mount Fuji in Japan. Then we have residual stroke dome mountain, which is formed by the uplift of crustal domes or erosion of ancient ranges. The feature is that it is usually isolated and rounded form. Example of residual mountain is Black Hill in US, Ara Valley Range in India. Having known that, let us look at hills and hill range. By way of definition, a hill is lower than 600 meters. That is to say that a hill is lower than mountain. It is gentler and more rounded than mountain. The formation, it can be formed in three ways. One, eroded remnant of old mountain. So it can be formed by the eroded remnant of old mountain. So it can be formed by the remnant of the old mountain. It can also be formed by minor tectonic uplift. It can also be formed by the deposition. Example, glacial hills. The hill range is linear chain of hill, often the final stage of mountain erosion. So hill range is linear chain of hill. So it is the linear chains of the hill, often the final stage of mountain erosion. Example of hill range is Shivalik Hills, that is food hills of the Himalayas. Importance is that it is significant to agriculture, settlement, and moderate climate. Now let us look at another physical feature of the earth, which is plateaus, that is the tablelands. The plateau is extensive, elevated, flat top land with steps aside, that is escarpment. The key features of plateaus is that it is high elevation, flat topography. It is deserted by river, example Grand Canyon. It is often mineral rich, so plateaus are mineral rich in nature. The formation could be in form of uplift of ancient, stable crust blocks or massive lava flows. So this is a plateau. Plateau is kind of extensive top flat land. Having known that, let us look at major types of plateaus. We have intermountain plateaus, which is usually located surrounded by the mountain. Example is Tibetan Plateau, that is the world highest plateau. Then we have volcanoes plateaus, whose formation is successful fluid lava flow. Example of volcanoes plateaus is Deccan Plateaus in India. Then we have Piedmont Plateaus, which is usually located at the foot of mountain near plains or seas. Example is Patagonia Plateau in South America. Having known that, let us look at plains, that is the cradles of civilization. By way of definition, plains may be defined as extensive, lower laying, flat or gentle rolling land. So plains are lower than plateaus. So they are extensive, low laying, flat or gently rolling land. The key features of plains is that it is minimal local relief. The primary process is disposition. So the process of formation of plains are usually occurred through depositions. Global importance of plain includes it is the world's most productive agricultural region and densely populated area. So this is the importance of plain to globally. It is the world's most productive agricultural region and densely populated area. Now let us look at formation and types of plain. Just like we said, the disposition is the main formation of plain. So we have dispositional plain, which is the most common. Under it, we have alluvial plains, which is caused by river deposit. We have glacial plains, which is caused by glacial deposit. Example is North American Midwest. Then we have coastal plain, which is marine deposit. Example is Atlantic coastal plain in US. Then we have Loess plain, which is wind blow seed deposit. Example is Loess Plateau in China. Then we have erosional plains. These are the ones that is caused by erosion. The formation is that it is prolonged leveling of older landform. Example is Canadian Shed. Now let us look at weathering. That is the breakdown. By way of definition, it is in-shoot on-site breakdown of rock. So weathering is the process of breaking down rock. So it is in-shoot on-site breakdown of rock. Types of weathering, we have physical stroke mechanical, which is integration by frost, heat, and pressure. So it is caused by the disintegration of heat and pressure. Then we have chemical, which is the disposition by water, acid, and oxidization. Then we have biological weathering, which is breakdown by root, lynches, burrowers. The result is this: it creates regoliths, that is rock loose material ready for erosion. Now let us look at erosion and disposition, the remodeling theme. Erosion is the removal and transport of weathered material. The agents of erosion include weather. The agents of erosion include water, which is river and wave, wind, and ice glacier. Then it creates valley, canyon, and sea cliffs. Now, disposition, on the other hand, is the dropping of transported material when energy decreases. It creates deltas, beaches, flood plains, sand dunes, and moraines. The result is this: it builds new, often fertile landform. The sculpting process, that is weather uh, uh, disposition circle. The continuous circle is weathering, erosion, transportation leads to disposition. So the continuous circle that distance Earth surface is from weathering to erosion, erosion to transportation, then transportation to disposition. That is Wade's circle. In conclusion, landforms are a temporary snapshot in Earth's long history. Mountains are built by tectonics, tectonics, then slowly carved by erosion. The sediment from the mountains are deposited to the form plains. Plateaus stand as ancient witness rich in resources. Understanding this system is crucial for sustainable resources use in agriculture, hazard management like flood and landslide, conservations of ecosystem, as well as appreciating the physical foundation of human history. Thank you.